Okay, let me start the course. Okay, so we are in the PDE partial differential equation. So I also use the abbreviation PDE every time. So you should know what I mean. So I hope you all get the ideas. Okay, so the PDE has been abbreviated in PDE when we talking also as well as in the notes also I have used sometimes. So it means the partial differential equations. Okay, so let's just recap our last lecture and just we can continue. Okay, so first of all, we are in the first outcome, learning outcome, which is define the basic terms related to partial differential equation. So that is also in the chapter 1, we are in the introduction part. So we have finished basic definitions as well as classification of equations, and also classification, solution, and formation of partial differential equation is our today's task. So with that, hope you have finished our chapter 1. Okay, now, so first of all, we have seen some definitions, real definition of partial differential equations. So as you can see, this is the functions of the dependent variable as well as these are independent variable. So when we're defining the partial derivative with respect to u, I mean partial derivative of u with respect to x, we consider all other y z t as a constant, and we just having small differences between x plus h and x divided by that h, taking the limit h tends to 0. Similarly, we can define da bar u over da bar y as well as da bar u over da bar z, and of course da bar u over da bar t. So hope you all get that idea. So I'll give you a small exercise on it so you can start work. Okay. The exercise is, and right here, let's say u, f, everything, I think you can distinguish, okay? Let's our function is y f is equal to x plus y square. Can you find the da bar f over da bar x as well as da bar f over da bar y in using this definition? Just use this definition. You can try, see whether what you get the answer. So I'll give you the answer as well. You have to get 1. Can you try? Sorry, not a 1. This one will be 2. Okay, can you try? I'll give you 5 minutes or something so you can start up your work like that. Use the definition to answer this question. Okay. Can you all try F or U? These kind of, these are, in this question, this is our dependent variable. What do you think? The independent variables are X and Y, isn't it? So according to that, using the definition, can you find da by for da by X and da by for da by Y? I already gave the answer as well. See whether you can reach that answer using the limit knowledge. Okay. You are trying. You're finding any difficulties, so you can. talk to me through the chat. Okay, now you can start up the work. So I'll try the first one. Okay, so give me a second. Okay, so our function f is equal to x plus y square. So if I am doing taking the derivative with respect to x, I need to keep this one as a constant, isn't it? So my definition is limit. So this is the way if in somewhere if they ask you to find the derivative, it's using the definition. This should you have to do. Okay, so limit let's say h or delta x anything. Okay, so for example, let's take delta x tends to 0. F of this one is like this, no? F x comma y. Okay, so x plus delta x comma y minus f of x comma y divided by the delta x. Is that okay? Now we have to substitute what is fx plus delta x. So this is our fx comma y. So if you substituting for the x, we have to substitute x plus delta x wherever the x is. So we'll have x plus delta x plus y squared. So we don't have nothing in the y. So this one x plus y squared. So is that okay? So divided by delta x. So what do you think? If you calculate this one, so x plus delta x plus y square minus x minus y square. So x square will be cancelled out. Y square cancel out. So delta x divided by delta x will be 1 is the answer. Okay. Can you write down and if you have any mistakes, please can you correct your mistakes? Okay, this is your homework. Okay, so you try like this way. So hope this will be a very simple things. Okay, so this dabba for dabba, yeah, sorry, dabba y will be 2y. Is that fine? Any difficulties or anything you want to ask me? You can ask. Erase the things. Okay, so I'll give you one or two exercises for you to try use. Okay, so you can use the definition to try these questions. So exercise number 1. Can you try f x comma y? Sometimes they will give you f x comma y. Sometimes they just give you f. So you have to know how to find out the independent variables. So let's try x cube plus x squared y cube minus 2y squared. Okay. Please write down nicely. I didn't write. I'll try again. Okay, give me time. Okay, our exercise will be first one fxy, which is equal to x to the power cube plus x squared y cube minus 2y cube. Okay, try this one and one more thing. I think this is enough. Okay, can you try these answers and find out what is dabba for dabba x as well as dabba for dabba y? Is Similarly, you can search some questions and try yourselves. Okay. So please note down this question. So let me continue the notes. Okay. So we know how to use the subscript notations to denote the partial differential equations. For example, da by u over da by x. We use the derivative, whatever, if it is f, fx, u, ux, okay? Similarly, if this will be show us which with respect to what, okay? So this will be the dependent variable. This will be the independent, which independent variable we are taking the derivative is the notation, okay? This will be very handy. Most of the books also using this one. Okay, this one, next one also, you can see, I mean, for example, this one also you can use. Some books use like this. I mean, da by x of da by da by y as uxy as one of the student found. But anyway, according to the book, you understand the question and do it. Okay. Most of the case for the things we'll get the uxy is equal to uyx. So okay, for the exercises I gave you already, you also can try what is, I mean, for example, fxy, what is fyx, see whether it is equal or not. Okay. So you can try the both equations to find whether these are equal or not equal. It depends on the questions. Okay. No need to be equal every time. But if it is, there are more, many situations, it is equal. But there are situations also arrive, it is not equal. Okay. So according to that, you can try, okay, using this I mean, definition. Okay. So you try this one or either try this one. Both are, I hope, the same things. Okay. Okay. I will continue. Next things. So I clearly explain each and everything. So I don't need to go, again. So you'll go through again what it is. And again, we had what is the definition of partial derivatives. It means containing partial derivative of function of two or more variables. And then we have seen these things as well as if you are taking with respect to x, then you have to keep the other independent variable as fixed, as like a constant. Okay. So next thing is we have seen what is definition of order of the partial differential equation, which is the highest derivative appear in the equation. And degree of the PDE also exponent, greatest exponent of that higher order derivatives. So we have seen all these things. How about the linear one means? Linear means the dependent variable and derivative appear in terms with degree at most 1. Okay. So otherwise we call non-linear. So these are also we have seen, and homogeneous and non-homogeneous and superposition principle. So this is where we have stopped, I guess. Okay, so what do you think? So if you are getting homogeneous means we have, for example, again. So homogeneous equation, even I forgot sometimes, so you have to be careful, okay? So if I am making any mistake, tell me. So LU, if any equation L with respect to U is equal to G, okay? So then it's called, if G is equal to 0, we call homogeneous. G not equal to 0, we means non-homogeneous. So this is the important thing. It's called homogeneous if G is equal to 0. Okay, if G is equal to 0 only, homogeneous. If it is something there, for example, e to the power x after the things, there's O plus x sin x, something like this. Depend on only the independent variable functions available. We called as this terms, this entire equation is non-homogeneous. But if it is only, we have only 0, we call as homogeneous. Okay. So according to that, you have to take all the other terms one side and this independent terms one side. Okay, so using that, if you are having a homogeneous case, linear homogeneous case, if you are, you may, in the next things we will see, we will end up so many solutions for one equation. So in that case, the linear combination of this of alpha ui also solution of this for the homogeneous case. So if it is come to the non-homogeneous case, we have to do one small differences. So if you get the idea, it is fine. Okay, that means if it is a non-homogeneous case, non-linear homogeneous equations. For example, let's say LU is equal to G, but that is not equal to 0. I think this should be linear non-homogeneous like that. Okay. So if it is so, you have this n number of solution for this case, no, only homogeneous case, and this solution for the non-homogeneous part. So all together, adding all together, we will get the solution of this equation. So if it is coming as a non-homogeneous case, we have to do one part is homogeneous part answer, then we have to solve the other part and all together only the answer. Okay. So we can see when it is coming to the examples. Okay. So that's all I think we have finished last time. So let me, okay, this course also, if it is finished, please join again. Anyway, we're gonna have today 1.5 hours, so we can do 2 times. Okay. Okay. So lecture 2. So I have sent you the notes now. Sorry, I was late. Okay. So I hope you all get the things. So let's start the continuation. There is one more definition which called scalar PDE as well as system of PDEs. Okay. So what do you mean by scalar? Scalar means maybe like 1 PDE or like that. Okay. A PDE with only one dependent variable, only, for example, U, or F, or Z, or any capital letter or any alphabetic letters we use for dependent variable. If you have only one available, for example, da bar U over da bar X plus da bar U over da bar, sorry, da bar U over da bar Y times da bar U over da bar, Z, or anything. But only the dependent variable is one, the same thing. Okay, only one dependent variable available, we call as a scalar PDE. On the other hand, if you have more than one dependent variable with more than one equation, for example, if I have da bar u over da bar x, if I use ux plus uxy minus uyy, whichever, right? This is one of my equation. Other equation is, let's say, fy minus fyy plus 2fxy something. So you have to solve both 1 and 2. Or sometime in a one equation also you'll have ux plus fx uy something. Okay. So if it is so, if it is a system of equation, we have called as a system of PDE. So if more than one dependent variable with more than one equation. Okay. So these are called as a system of PDE. So like the algebraic equation, for example, if it is only one example, let's say x square minus 2x plus y, sorry, not y. So x cube, which is equal to 0. So in this only one variable. So if it is system of equation, we have like this, x squared y minus xy squared is equal to 0. And again, y minus y cube is equal to 0. So if you wanted to solve these 1 and 2, there are two variable, two equations. So this is kind of a system of equation algebra. Similarly, for the partial differential equation like this. Okay. So the concept is same. So I hope you understand that. So that is the definition of scalar PDE as well as this system of PDE. Now let's see. These are some of the I mean, very important PDEs. We can say, okay, that are used in our real life environment. So, for example, in the physical problem, in the physics also. Okay. So this is a famous PDE we called as a heat equation. Okay, in one space variable. So what do you think? One space means, so if you have three-dimensional x, y, and z. So if you don't consider this or this, only we are considering one way in this axis only. Okay, for example, the heat equation where you can have, for example, if you are heating one, I mean the rod. Okay, or in the physics, you can see. I think if you are you know heating one side, so this rod will be heated up every point and entirely it will be heated up. Okay, so we can derive this one. I think in the fourth chapter also it is coming back. Okay, this is one of the famous uh, partial differential equation which called ut, which is equal to alpha square uxx. So what do you think here? T. So always the t has same thing, no? What do you think? We know x, y, z. So because only we are considering x direction, the x is x only coming, not y or z or nothing. Only in this direction only we're gonna see. So one dimension. We call one dimension. Okay. So what do you think the t here? Can you answer me in the chat? Why we use it has many meaning, but most usually we use the t is for what? Okay, I have one answer. Let's see. Okay, good. How about this? What do you think? T is for like X, Y, Z is for spaces. Yes. T is for time, isn't it? Always time. Here also it means the time. Okay. So if you are derivating our heat dependent variable with respect to time, which is equal to alpha squared is a constant. Okay. So we can see when it's come. Then uxx. Okay. So 2 times. So can you write this one in terms of our actual way? How you can write this without the subscription? But how we can write alpha squared uxx? So can you write down? So daba like that. So this one will be daba u over daba t. This equal. This is a constant alpha square. This will be what? Daba squared u over daba x squared. Okay, so this moment is called as the heat equation in one dimension. Okay, so for example, if I have, let's say, something alpha time u y. So what do you think? How many spaces? Please answer me quick as possible. If I ask, every time you check with me, give your answers. Possibly some answer you can't type, so leave that one. But if whatever I'm asking which can be typed, can type well, you can send me. So which dimension? So if you have uxx plus uyy, so I can take the alpha command. Okay, ut. So this will be, yes, 2-dimensional. Similarly, you can have 3-dimensional also. That's it. Okay. Okay. We have only 3-dimensional so far. Okay. We don't go 4-dimensional, 5-dimensional for our theory part. Okay. Similarly, this is we called as a wave equation. See, this will be ut alpha square ux. That is a heat equation. Here, I will ask you in the chapter 4 also. Okay, it will come to solve. So that time also we can come across this one again. But these are some of just to introduce you some famous PDE. Okay. So what do you think? So UTT means I mean partial derivative of time, and c squared. So not alpha square, C square are same, something, okay? Maybe, for example, alpha square may be thermal conductivity, conductivity of the rod. Okay, those things, those are physical things, this one, no? Maybe alpha square something else, according to the wave equations. So uxx plus uy in two space. Why? Because this one and this one, we can say this are 2D variable. Similarly, this one we call the Laplace equations in polar coordinates. Okay, so we have seen this in the vector calculus. What do you think? Laplace equation. You remember something? This one is equal to Laplace equation. We call that one. And polar coordinate means maybe cylindrical or spherical. Okay, I'm going very far because these are known things. I don't want to waste time here. Okay, so you just go and try find out some others also there. Okay, our session will be finishing within 10 minutes, so we can meet again. Okay, how about this one? Ut plus Cux. You don't need to memorize now. It is not important. He just showing some famous things only. So this is we called as a convection equation or advection or transport equation. Okay, so we can, I think physics, it may come early also. So this is that. Okay, so let's continue how the solution of the PDE. So this is what a little bit of things why we are here. Okay, so solution of PDE. So what it says, a solution of PD is any function u which satisfy the PD identically. Okay, for example, so in algebraic equation, let's say x squared plus 2x plus 1 is equal to 0. So how we can solve this one? There are so many ways, no? We can take the, this one is equal to 0. If it is squared, we have two solutions. For example, what is that? X minus 1, x minus 1. So x minus 1 whole again square. Am I right? So x equal to what? Is that 1? 1 comma 1, isn't it? There are two solutions, so 1 comma 1. So if it's so, similarly, if you wanted to solve, let's say dabba u over dabba x minus what is that? X dabba u over dabba y something. After we didn't see the solution method yet, but if we solve this one, see, we are solving x squared to get the answer x. Similarly, our function is u, no? So whatever we're gonna get, let's say, for example, my answer is this 2y. So in the solution, we won't get the u, no? Am I right? Here, see, in the algebraic equation, the solution is there x. If it is x, it is wrong, no? In the algebraic equation, you have to get the answer of any scalars. Similarly, this is a partial differential equation. So this is a partial the function of variable x comma y. So this is a function of x comma y, no? So this will be the solution. So this, for example, it's not a solution for this one. I'm just saying. So if this is a solution, see here, the solution of PDE is any function u which satisfy the PDE identically. Okay. So if I am taking the dabba u over dabba x, again dabba u over dabba, and substituting this LHS part, I need to get 0. Then my answer is correct. Similarly for this one, no? So if I substitute here 1, I'll write again. Okay, for example, if I have the algebraic equation, I'm using the algebraic equation for you to distinguish the things and understand the concept. Okay, so this my answer will be, let's say, x equal to 1 comma 1. Sometime if it is, for example, 3. So sorry, this is can you give me one equation which gives the answer 1 comma 2 or 2 comma 3? What is that? So x squared minus 5 plus 5x. Sorry, minus 5x, no? Minus 5x plus 6 is equal to 0. Am I right? If my answers are 2 comma 3, my equation is this one. Can you check and tell me, is that the equation for this one? How to find? If you get the plus answer, this should be minus, no? Am I right? X minus 3, x minus 2 will be the answer for this question. I mean, so if you equate this both equal to 0, you'll get 2 comma 3. So this will be my equation, am I right? These are school level thing, no? It should be correct. Yes? Okay. Others, can you answer me? Am I in the right path? If I want the answer 2 comma 3, my equation should be 5x plus 6 equal to 0. How about x equal to minus 2 minus 3? That is the equation. So if you want the answer minus, this should be plus, no? Plus 5x plus 6 should be, this one, no? X, and minus 2 minus 3. We can multiply these two and add these two like this. These are algebraic. Okay. This is how the answer concept, working here as well. For example, if you are having da by u over da, I'll write ux minus 3uy or something. We not study it how to solve it. If you solve, let's say my answer will be x cube minus 3x is, y square or anything. Okay. So if I wanted to, see whether it is my answer, what you do? In our elementary differential equation or ODE, what we have done. If you wanted to check whether it is my equation, even for example, if that's why I took this equation, if it is algebraic equation, if it is my answers are 2 comma 3, how you can check whether this answer is correct or not? What do you call? How you can, check whether your answer. You don't need to wait for, teachers to correct. You can correct even in the exam hall, exam paper. You can correct yourself whether you are right or wrong. No. Okay. What is the idea? Let's see. Okay. Good. Why I am getting only one person answering? Where's the other? Everyone sleeping? I know this is sleepy time. I took extra time anyway. Okay. I need to finish 3:30, so you can have some rest. Yeah, we're having lecture before. Okay, so that's why I made it to 3:30. Please answer me. What do you call the checking this answer to this one? How to check? What is the idea? Yes, one person answer. That is correct. How about others? Yes, good. How about two persons correctly answers? Where's the others? What we call using this answer, how we can check this answer is correct or not. We can also call substitute it or verify it. Okay. So we can verify by substituting. Okay. So let me check. So for example, take out this one. For example, if it is my u is equal to x cube minus 3 2y square, how I suppose find? You can find da by u over da by x and da by u over da by y and find a equation using this one, no? So we can see in the solution methods. Okay. So this kind of things. So what they are saying is the solution. So sometimes they may ask, define the term. So write down this question and find the answer. Define the term solution of PDE. Okay, if it's so, what is the answer? The solution of PDE is any function u or f which satisfy the PDE identically. Identically means it should even because we are considering daba u over daba x, where we are taking y as fixed. And when you are taking daba u over daba y, we are taking x equal fixed. So we are keeping something other one as a something. Okay. So it should be satisfy this one and this one at the same time. Okay. Then that what we call as an identically. That is for all possible values of the independent variable. For any values, it should be identically satisfied. Okay. So you can write in your own words. So if this question comes, this will be the answer. Okay. So write down here the things. So you get the question, you can answer. And also the usually the solution of PDE is not unique. Okay. See here. But in the ODE, we are dealing with the one variable now. Only X or Y or anything. Okay. Only one variable. Because of one variable,